Okay, this is the last video in this little series devoted to proving that opposites attract. Now, for this advanced routine, we need 12 cards, 6 red and 6 black. And the card values are not important, okay? So if 6 red here and 6 black, spectator can freely decide how to stack those packets together, okay? And then I'm going to just begin to really mix these cards here. Okay, it's called the Klondike Shuffle if you're interested in the name. And now we're going to just mix these cards using the Charlier Shuffle. Charlier Shuffle, it's a good way to just scramble them. Now, I need you to choose a number between, let's say, 4 and 8. And the reason for that range is so that we have a decent number of cards in each pile. So what would you like? 5? Okay, so I'll just push off. Is it 5? Very good. So we're at 5 here, 7 here. Okay, I need you to randomly flip either packet. This one, okay? Okay, now what we're going to do is a rosette shuffle. This is where you just spin them and then just have the cards come together in some messy fashion like that. Very good. Okay, now to further mix these, I'm going to have you tell me if you'd like the cards left as they are or flipped over. Leave or flip? Leave. Okay, what about these two? Flip. Flip. What about these two? Leave. Flip. Okay. Leave. Okay, so we did that for pairs. Why don't we do it for 4 at a time, just to really mix these? You want flipped, leave, flipped. Okay, very, very good. Now, what we're going to do is we're just going to continue to scramble these crazy cards. And I'm going to deal them out into 2 piles. Now, you can decide whether we stack the left pile on top of the right or the right pile on top of the left. Which would you like? Right on left? Okay, that's very, very good. Why don't we do one more of those? We'll do some additional mixing where you're given all the choices. You want left on right this time? Okay. Why don't we do 3 piles just to scramble these crazy cards? Left to right or right to left for our stacking? Right to left. Okay, very good. Why don't we do 4 even? Okay. Now with 4 piles, we can do quite a bit actually. We can do a stacking from left to right, right to left, or we can even do something called leapfrog stacking. It's kind of fun to do. So would you like to try that? Leapfrog stacking? Okay, which direction? Left to right or right to left? Right to left. Okay, so this is where this one here leaps over its neighbor, lands on that one. This one leaps over its neighbor, lands on this one. How would you like these stacked? Left on right? Okay, should we do another one of those? Okay, do you want leapfrog stacking or just ordinary left to right, right to left? Just left to right. No leapfrog this time. Okay, very, very good. Now, what we can also do to just mix these cards beyond the knowledge of anyone is we can perform something called an up jog. And it's actually a pretty useful shuffle to learn. So this is where, like an even up jog, this is where you push forward or jog forward the even position cards, the ones that are in even positions, 2, 4, 6, 8, 10, 12, right? Strip those out. How would you like these stacked? Right on left? Okay. And then maybe to do some final dealing, why don't we deal out into 6 piles? Whoa, 6 piles. Should we stack from left to right or right to left or leapfrog? You want leapfrog? Which direction? Left to right. Okay, so we'll leap over its neighbor. This one leaps over its neighbor. This one leaps over its neighbor. That one leaps over. And how would you like these stacked? Left on right? Okay, very, very good. Now, to finish up, I thought what we would do is just deal them out into 6 piles, like so. Now, since we're trying to prove that opposites attract, instead of dealing them out again kind of in that same order, I thought we would just deal them in reverse, okay? So deal them in the opposite order to which we just did them. Okay, so let's see how we did. Have we actually confirmed that opposites attract? Let me bring this back on camera. Sorry about that. And this one too. Okay. Well, let's see. This one here, that's black. I really hope this one's red. Oh, it is indeed. This is black. I hope this one's red. Oh, yes, yes. Oh, well, that one's already fine. Great. Now, what about these? We're wanting a red and a black to show that opposites attract. They do indeed. Oh, this is red. I sure hope this is black. Oh, it is. It's even the same value. Isn't that nice? And what about these? Opposite color? Yes, indeed. We have confirmed for the whole world to see that opposites do, in fact, attract. Okay, well, let's look at some of the mathematics here.